ಕಾಲೇಜ್ ಫೋನಲ್ಲಿ ಇಟ್ಟಿರ್ತೀನಿ, ಇಲ್ಲೇ ಇಟ್ಟಿರ್ತೀನಿ.
Very good evening, sir.
Good evening, everyone.
I hope all delegates, am I audible to everyone?
Yes, sir, audible.
Thank you.
Am I audible?
Yes, sir,
Yes,
audible.
yes.
Okay.
So again, a warm welcome and very good evening, all dignitaries, respected faculty members, our respected resource person, Dr. Atul Juneja, sir, and all delegates presented in today's live session of 3-month certificate program on Research Methodology and Biostatistics. It is an honor and privilege to introduce our distinguished resource person for today's session, Dr. Atul Juneja, sir. Sir brings with him an unparalleled wealth of knowledge and experience in the field of biostatistics and clinical research methodology. He has made significant contribution to the medical community through his extensive research, teaching, and leadership roles. Dr. Juneja sir's illustrious career began with ICMR project at Kalavati Saran Children's Hospital in New Delhi in 1982. Over the years, he has held several key positions, including statistical assistant at ICMR headquarters in 1983 and granted 3 advance increments for outstanding performance in selection process. Also worked as a technical officer at the National Institute of Cancer Prevention Research. His career is marked by numerous achievements, particularly during his tenure as a scientist F and coordinator of the Clinical Trials Registry India CTRA and the ICMR National Institute of Medical Statistics. In this role, Sir was instrumental in enhancing the transparency and rigor of clinical research in India, notably expediting the review of COVID-19 research during the pandemic and developing a news module for the registration of Ayurveda trials and presented the development on CTRI through various scientific forums, including invited talks. His academic and professional journeys decorated with awards such as Srimati Suraj Kalijan Award for Young Scientists from the Indian Society of Medical Statistics in 1990 and 1996, and a full fellowship for presenting research at the Asia Pacific Conference on Sexual Health and Rights in Beijing, China. Dr. Juneja sir has also contributed to numerous impactful research projects, including studies on the impact of COVID-19 on maternal child health services and comparative study on methods of assigning cause of death supported by WHO and Ministry of Health and Family Welfare. Currently, Dr. Juneja sir serves as an associate professor guest at ITRA College in Delhi, a visiting consultant in biostatistics at PSRI Hospital, and a visiting faculty at Nehru Homeopathic College and Hospital, New Delhi. His dedication to education and training is evident through his involvement in teaching research methodology and biostatistics to various postgraduate and professional programs. Dr. Juneja sir's prolific contribution include authoring 65 research publications, with 27 as the first author. He has attended over 70 national and international conferences, which includes USA, Canada, Singapore, Malaysia, and has been invited to speak at numerous capacity building programs. Authored the course material for the MPS program for International Institute of Population Sciences. His membership is in prestigious professional associations and committees such as National Academy of Medical Sciences, the Indian Society of Medical Statistics, Indian Society for Information Theory and Applications, and life member of Indian Association for Population Sciences, further attest to his expertise and commitment to the field. Sir is presently also member of various scientific committees as IEC member of AIMS New Delhi, member of National Advisory Board for Journal of Case Reports published by All India Institute of Ayurveda, member of Scientific Advisory Committee, Clinical Research for CCRAS New Delhi, and member of DNB Research Committee of PSRI Hospital, Akash Hospital, National Heart Institute at New Delhi. Today, we are indeed fortunate to have Dr. Atul Juneja sir with us today, and please join me in welcoming the resource person for today's session, our respected Dr. Atul Juneja sir. Please, sir, welcome, sir.
Thank you so much, Tiwari sir, for your very kind words. I'm really humbled with your. I would humbly request you that presentation आप चलाइए वहाँ से. It will be more comfortable for me. I'll more concentrate on talking to my dear friends. Hope you're comfortable with that.
Yes, I'm just sharing, sir. with their
Okay, no,
second.
no issue, no issue. Absolutely at your comfort. Sorry to bother you.
Yes, yes, please.
Good morning, friends. It's a pleasure and honor to be part of this workshop, which I've always enjoyed, cherished, and appreciate the efforts made by Institute of Applied Statistics in collaboration with various agencies to disseminate the knowledge of research methodology to each corner of India, reaching out to the smallest places in India through online programs and of course offline programs. I have always mentioned that, I mean, that it's always nice to be connected to all these programs and I always enjoy it. The most important thing which I miss is your physical presence. I can't see you. So anyway, but the effort from the Institute of Applied Statistics to reach out to a larger number can be done only through online programs. And so that's okay. As I said, that I always enjoy interacting with the students and asking questions midway and trying to mold my presentation what actually you look forward to actually. So, but that is not possible here. But I'll do my best to present what I am intended to and what I feel based on my experience that would be most suitable to you and suitable to you, appropriate for you, and most importantly, in the end, sustainable. Because what we learn is important. How we learn is important, but whether it is sustained or not, that is a question mark. Many times it happens. So I'll try to make the things in a simpler way that you enjoy it and it goes with you for a longer time. That would be my effort. So the topic, as I've always mentioned, the topic which the institute has always picked up are in very line with the day-to-day requirements of the researchers, young faculty, new researchers, and the sequence what they have put is really appreciative. And even the smaller issues are addressed. Usually what happens in lectures, those smaller issues are part of major, I mean, any other topic, but they have done it such a way that data quality is taken in a different way, parametric test in a different way, non-parametric variables, etc., etc. I mean, they have done in a way, divided the program into micro details, which I feel, which helps the sustainability of the subject. Well appreciated. So the topic which is assigned to me, you all know it, data quality and master chart preparation, right? So I'll majorly focus on data quality. Right. Of course, it's not that master chart. I mean, I have data quality is a very major topic, and I mean, one can talk in hours together. And let me tell you how its importance. Recently, a few years, I mean, not few years, just a year back or so, ICMR had launched a program on National Data Quality Forum, which was inaugurated by Dr. V.K. Paul, the Niti Aayog member of health. So the point was that the data quality we have been listening about it since our when we start learning statistics, when we start learning any basic research, data quality becomes a very important part. But its importance, why it is important, we'll look into it as we move with the various presentations. As you all know, let me start with a very basic thing. What is quality? I mean, quality means before that quality, anything you have it, all have to have some quality. It is not only data. Let's start something. So everything has to have some quality. Quality means, what do you mean by quality? Of course, you know that word. Quality is a very simple English word, but what does it mean? So many times we think kya hoga quality ka matlab. Quality means there are certain standards which are expected on the item we are dealing with. May not be data. Well, I'll come to data later on. Anything. You buy electronic item, you buy anything, any food, somewhere you have put in your mind certain standards, what you expect to have on that product. And then only you move to have it. So suppose you're buying a TV. Let's say you're buying a TV. So one TV is something like 35,000, another TV is something like 40,000. Now, I mean, you decide that the shopkeeper says that this is slightly better, you will have a better view. But you look at the things and spend some time at the showroom. And finally, you say, what is 35,000 is okay. I'm not able to distinguish Distinguish means I'm not able to significantly distinguish between what he's telling for 40,000, what I mean you have identified for 35,000. You feel it is not worthwhile to go for that extra 5,000 rupees. So it is your standard which you have put. So quality is not a very well defined, it is a relative term, and as it goes with the data also. And let's see how we come up with the things. So certain defined standards, so which have to be there for generating a data so that we have the right results what we are looking for. So that is the main in one line, that what kind of results you're going to have is based on the data quality. And data quality, let me tell you, and any product, coming back to that example again, and any product what you have is, suppose it's being manufactured through a process, so it needs a raw material. So raw material has to have the quality, then only the product. It is not only, suppose you have a very good raw material quality, but the process on through which it is passing through may not be very good. So if we talk about the health aspects or the health products, medicines or health devices, what is important? Raw material, of course, is important. We all know it, no doubt about it. But the process, manufacturing process is equally important. So what is known as, technically known as, you all might be knowing, GMP. GMP क्या होता है? Good manufacturing practice. So because including a raw material, you should have a proper process which is standard enough to deliver the goods. So it is same thing goes with the data, that you have to have a good quality data. Yeah, PPT is not moving. I'm not. I mean, I have not. I'm still on to introduction. So the data, it is not only the quality of raw data, but it's the process which it passes through has to have some quality. So I will try to comprehend what data quality means. It is not only the raw data we're talking about, the whole process I'll try to address and see. Next slide, please, Tiwari. So I'll start, as I've always told you, that I mean, you have had many with number of lectures. Let me tell you, every lecture you listen has some connect in the background. So whenever I start deliver a lecture, offline or online, I always try to connect certain basic things. They are, I mean, they are not to teach you, but they are to give the connect to what we are doing actually. So they might appear to be very simple, but they provide a connect. It's like a train. Every bogie in the train is connected. So all the lectures are connected. Sometimes we feel that kal ka nahi suna to koi baat nahi aagi. So usually the next lecturer tries to do in such a way that some connect is there, even if you have not listened to that. Okay. So statistics and biological research, you all very well know. This is a very important sentence. Although you must have heard in initial lectures, but still I would like to remind you. The use of statistics allows biomedical researchers to draw a reasonable and accurate inferences from collected information with a degree of uncertainty. So, I mean, degree of uncertainty क्यों बोलते हैं? हम जो p values वगैरह निकालते हैं, तो uncertainties को minimize करते हैं. हम always remember, I am not going to teach you right now that thing, but uncertainty को minimize करते हैं, हम zero नहीं कर सकते. We can't make it zero. Like p less than 0.01, p less than 0.0. Always remember, although many times the SPSS output gives p equal to 0, because it has truncated at certain decimals. That is why it is giving 0. P value kabhi 0 nahi hoti. That means what we are trying to do, I mean, I'm not teaching that. You must have had through in various other lectures, or we will have in future, but just these are just a reminder or of what the statistics is all about. Next. So data health, we're talking about, we're into health system. So we're talking about health. So what a clinician or clinical researcher looks for, जिसके लिए उसने data collect करना है, what we are looking for actually. Understand the disease occurrence, distribution and outcome. Simple. That means we're trying to understand if we look at the design of the study, what kind of design in this situation would be, is it descriptive study? We're trying to describe the population, distribution and outcome. Understand the phenomena of causation of disease, right? Then you move on to, I mean, what I'm trying to say, you must have had initial lectures on design of studies. देखिए इसमें क्या हो रहा है? Understand the phenomena of causation of disease. Why the disease is being caused. So we are moving on to cohort studies or case control studies, exposure related. Identify the length of causality that are amenable for intervention. Now this we want to the health system. We have identified the risk factors. So now we need to look what can be done. Suppose age is a risk factor, you cannot do anything about it. Only you need to have some idea about the load of the people in that category, and the health system can work for delivery of facilities to those people. But the factors which are amenable for intervention, the government, usually the health system, intervenes to improve it. Relate, and then what happens after that? You have put in some inputs, relate the output and impact of intervention programs to their input. So your input and what are the returns? So Janani Suraksha Yojana and all those programs tell us whether the hospital deliveries are getting promoted or not, and health, how the maternal health is getting improved. So these are outputs, what efforts have been put in and what are the so, and assess the effectiveness and the efficacy of treatment of drugs. What is this? Simple. This is a form. This form is a part of clinical trial, right? So this is all what comprehensively I have tried to put in 5 points, that this is the design of the study. What? So again, I'm trying to link with the other thing. Okay, why we are generating data? Just because of this, we are generating data. So next. What is data and data collection? These are basic things, we all know it, but always knowing it in a more organized way, in a specific way, helps us to maintain our knowledge in a better way. So data collection of information gathered by observations, measurements. Simple सी बात है, data collection क्या है? Of information gathered by observation or measurements. आपने कुछ observe किया या measure किया. Observe किया कि हाँ ऐसा something is happening. So you're observing. And something you're measuring blood sugar, you're measuring biochemical parameters. So by observing, I mean, the symptoms are written by observing or by asking the patient, but other parameters are measured. So that is the data collection. In just one line, data refers to any set of information or facts that is represented in its various forms. Now, I mean, we have talked what is data collection. Of data collection, कितने forms अलग होंगे, such as text, numbers, images, audios and videos. इनमें से कुछ भी हो सकता है. So that depends what to pick up based on our objectives. So we need to be very clear about it. Data collection is a process of gathering and measuring information on variables of interest. Now further we are narrowing it down. So what are the variables of interest? So you've got an objective. You need to have certain information through what? On certain variables. So data collection is a process to get an answer to the formal or informal queries or hypothesis. So now we have become, I mean, we started with a very basic definition. We came on to a scientific definition. But all these points mean the same. But as a scientist, we need to be specific what we're trying to. It's an hypothesis what you're trying to test. As a researcher I'm talking about. So you think that this drug works. Now you need to, I mean, your hypothesis is based on certain, your hypothesis has to have some rationale. So always remember, I mean, this additional point off track I'm telling. So when you are writing a protocol, always remember, if your rationale is good and you somewhere lack in, I mean, this just unofficially I'm telling, if you lack somewhere on methodology, still there's a likelihood that you might get your project through because your rationale is good. I mean, the observer, investigator, or the reviewer might feel that this needs to be looked into. So they can advise you to improve upon your methodology and approve your project. But in case your rationale is weak, and howsoever good you might have written, there's a possibility that the reviewer might feel that. So anyway, this is just a side point I have added for your benefit. So ultimately, the hypothesis, what you want to have generated, and to prove that, you're collecting a data based on nature of variable. Always remember, data collection is based on technically type of variables, which I'll touch upon in the next slide. Next. So what are considerations for data? Data consideration are primarily based on purpose or the objectives of or intent of research. Okay, simple. I mean, nothing new I'm telling, but knowing in a sequence way कि हमें किस चीज पे data collect करना है. That's simple. Which data to collect? That means we're talking about target group. Which data to collect? Type and nature of variable. Which approach to use? Through primary or secondary? Suppose you need to, I mean, any parliament question you need to answer in a short time. So you usually look for a secondary data. You look for papers and answer to the question. That's what we have been doing at professional experience. So who shall collect the information? अब आपको देखना है कि if it is a small study as a researcher, you could do it. But if it is a large study, you would need to appoint investigators. So that all depends. And most importantly, in the end, what's the time frame? Okay. Next. So data quality. We started with that only. In simple terms, data quality tells us how reliable a particular set of data is and whether it is good enough for a user to employ in a decision making. The quality is often measured through various criteria. So this is the simplest definition which I could find. And again, this is what it's not only data for anything, any quality you're talking about, how reliable and useful it is for you. Let it be any electronic instrument or a hardcore data of research. So whether it serves your purpose or not, that's important. For example, I'll come to those things, but I got a chance to talk to you about that. Suppose you have done a measurement very correctly. Suppose you're measuring a blood pressure and your instrument is good, or I mean, the whole data is of a very good quality, but your inclusion was wrong. Suppose you wanted to have the average blood pressure level of the students of the patients attending the OPDs of different hospitals. So as per random selection, it was a matter of chance or by selection, you could say, that hypertension clinic got selected. So all the values which you would be getting would not be random. They would be, because since it is a hypertension clinic, you already know it that the blood pressure levels would be high in these patients who are attending. So the information of the OPD would not be valid for this, although the measurements are correct. So this is as a result of biased information. We'll come to it later. Next. Research results are only good as the data they rely on. Data quality impacts the trustworthiness of conclusions. Very important. Data quality is crucial for human research. It impacts decision making. You have done some research, and if it is based on a invalid data, incorrect data, and you're making a decision, so what is being harmed? The human life is getting harmed. So it is very, very important, and the health system has given due importance to it. As I told you in the beginning, that National Data Quality Forum has a big project was initiated at ICMR with the support of Government of India, and just to promote that, why the quality of data is important, just to sensitize people and what are the considerations. So I've just picked up few of them. So data collection methods vary based on study questions and their approach of preaching. So you should know what kind of approach you have to use. Again, it depends on your objectives and facilities available to you and the time available to you. It needs to be personal interviews or phone-based onlines. These are all considerations you have to make before you really proceed to the desired methodology. Next. So now let's get more specific to it. We talked about data quality and we all understand actually. So let's see what the data quality means. First thing is simplest one is accuracy. It is a measure of correctness of data that is measuring what is intended for. You're measuring blood sugar, so your instruments are in order or not, whether they match with the standards or not. Again, standards based on certain criteria. Okay, what are the errors acceptable to you? So that is accuracy, blood pressure, blood sugar, whatever the measurements are there, or even symptoms. So you should be accurate in that. So now again, relating that example, what I gave you earlier, the measurements taken at the OPDs of hypertension clinic, the values were correct, absolutely correct. The instruments are very fine. The investigator was very, very well trained to take the blood pressure. The fact was that he had picked up a wrong selection, so that the average what comes up or the synoptic figure that comes up is not valid. Because suppose you get an average blood pressure of say 150, and then that may not be the case with the whole hospital. But since you have picked up a wrong thing, so this data might be accurate, but may not be valid. So, I mean, Of course, I'll come to validity later, but since this point came up, so just to make you familiar with it and easily you can remember it with these examples. I always believe that examples help us to remember or sustain the knowledge in a better way than what we read it in text or standard text. Standard text, of course, you cannot escape for your examination, for your interviews, you need to have. Coupled with the basic examples, it's easy to sustain the knowledge. So next is the completeness. Okay, suppose you have, I mean, your target sample size was 100 and you have collected data on 95 and it's correct, but still the data of quality would be less in terms of simple percentages or means or whatever you're taking, because it has a less sample size, and less sample size or improper sample size can lead to the wrong statistical decisions. You will have more lectures on that, on those things, sample size, etc. So I mean, what I'm trying to say, what we study, everything has something to do with quality. So I have tried to connect those small points with that. So completeness means, and some information you are lacking. I mean, suppose some people have not answered the questions for some reason. Those who are more sick, they didn't answer you the questions. So the results would be biased. And the third point is consistency. Standardization and uniformity of data across different sources, systems, or formats. Right? This is a technical definition. Simplest, you can take certain examples. Right? Suppose somebody, I mean, you're doing a survey and somebody says somebody is, let's say, middle income group. Somebody has an income of say 30,000, and there's some question in the end. Do you possess a car? Person says yes. The answer is which one? Then he says Mercedes. So there is a possibility. I mean, I'm not saying so. There's a possibility that data might be inconsistent. Something might have been done wrongly in picking up the. It is not that. So I mean, the data doesn't appear to be consistent, which needs for rechecking. So consistent means different items, if they are supposed to answer the connected things, should match. Suppose a lady, I mean, who is unmarried and answering that she has 2 children. So there is a possibility, I'll say possibility, that the 2 answers are not linking. So needs to be investigated. So that is consistency, and but written in a standard way, standard definition, which I'm presenting you all with standard text, but trying to put those things in as simple way as I can. Standardization and uniformity data across different sources. Now you read this, you'll find this in those 2 examples, the 2 different sources were not matching actually. Next. Next is, so continuing with the components of data quality, timeliness. If it is readily, timeliness means readily available, but is whenever it is needed. The dimension also covers keeping the data current. For dynamic data, timely updation is defined in system. Like suppose your data is moving, how many cases you have been registered in any registry. So suppose if it is a delay of 20 days or 10 days, then the data quality might be lagging. You think that the load is this much, but the fact is that the load was something else. So in case of dynamic data, updation should be defined based on certain criteria. It may not be instant, but it would be it depends on the nature of the work. Within a week's time is okay, or within a day it needs to be improved. That depends. Like for example, a flight time. Suppose it is given that the flight is 2 hours late, then it gets 4 hours late. So they are supposed to communicate as early as possible. Within it is not that, I mean, they, after 2 hours they inform. By the time the passengers might have reached airport and might be at inconvenience. So it all depends what kind of situation you are dealing with, and timeliness criteria is based on that. Next one is uniqueness. So avoid if there is any duplicacy of data, which is very common while data entry is being done. So now coming back to that point, what I addressed in the beginning is validity. Howsoever your data might be correct, measurement wise, everything is perfect, but the inclusion criteria was, I mean, it was wrongly picked up area. Suppose you are trying to study the disease in a state for a magnitude of a particular disease, and you happen to reach to a place through some sampling technique or convenient technique to an endemic area. and the results might be very different for whole state and for that area. So that data, howsoever correct might be through methodology, through measurement techniques and all, but may not be valid. For it, I mean, just simple example I can try to give you. Suppose Japanese encephalitis is very common in the Gorakhpur side area. Okay, but that does not represent the whole UP. Suppose, I mean, you have randomly selected that area, the person doesn't understand that concept, he doesn't know. So let's say, I mean, assuming a hypothetical situation, and he picks up specific endemic district for that, and that sample, why we do sampling? Now coming back to that sampling, we do sampling because to project the results most near for the bigger population. So the results what we get from that uh, district and we try to project for whole state may not be correct. So that means the data is not valid. Although all the components what we have talked about earlier are matching. The data is perfect, everything, but the selection is wrong. So we are saying that the Japanese encephalitis is X%, but that might be because of the endemicity of that area. So that is called validity. So reliability is also a factor. Reliability refers to of course, validity and reliability can be talked in a very different lectures, full lectures, 1.5 hours lecture, but still I have tried to, and as I have tried to summarize in one capsule the whole content so that you don't miss anything as far as I can think of. So reliability refers to the consistency of measure whether results can be reproduced under the same conditions. So it is a basically reliability is a repeatability, to put it in a, and it is the stability of measure. So these are very set definitions. Reliability means, suppose you're measuring blood pressure and somebody else measures and it is a different for a same person. So that means the readings are not reliable. Right? Next. So there are, I mean, this is just one slide I have put, internal and external reliability. So within a system when you're working, suppose you have designed a performer. So all the questions inside, I mean, suppose you're trying to address certain aspects. So all the questions are addressing the same aspect. You should, I mean, there should not be any contrast. On one question, somebody is answering that way, and the similar question, the answer is quite contrast. So that is internal. External reliability means that same performer can be taken to other places also of the same. So external reliability, and just, I mean, of course, this can have full-fledged lectures just to touch upon our next. So this is just an interesting example I got. So this is what is there. I mean, all the arrows are getting at a corner area, but not reaching this middle one. So they are precise. Okay. So they are, I mean, if I put it in terms of reliability and validity, they are reliable, but not valid because you were supposed to hit in the middle. But all are getting concentrated on one area away from the thing. That means reliable. So that means the arrow which is the bow which is hitting this is moving on to one point. Just reliable, but it is wrong. It is reliable but not valid. Second one, it's neither reliable nor valid. All scattered here. So third one is not precise, not accurate. Again, same thing. And what is happening in the last one? It's all are reaching in the middle. So it is reliable as well as, so contrast one is first one and the fourth one. First one is reliable but not valid. Fourth one is reliable and valid also. So valid is the correctness of measurement, reliability is the repeatability. That means we know that this will happen even if it is wrong. Next. So just, I mean, again, a additional slide which I have put it. So types of bias in clinical studies which can affect the quality of data in spite of having all the good quality measurement techniques. Selection bias, I have already explained. Ascertainment bias, wrong diagnosis with bias intent. Yes, suppose you're conducting a clinical trial and for symptomatology, you might ask the question in such a way that the patient's answers in a way that what you're looking for. So that introduces a bias in the study. Attrition bias is a very important one. Loss to follow-up. Suppose a particular group of patients are getting lost, not patients, participants, I should say, are getting lost. So that means the results what you're getting are likely to be biased, because certain group of patients with specific characteristics were not coming. They were with the severity of the disease, or who felt that the drug is not working for them, so they drop from the study. So you might have a chronological bias when time is a potential confounder. Suppose the risk factors changes over time, the exposure changes over time, right? Changes in exposure risk over time. Uh, so those can be considered as bias. So they can introduce the quality component. Measurements might be right. Co-intervention bias. So suppose somebody is getting something else along with the standard drug what has been proposed to study its outcome through a clinical trial, but he or she is having some other co-intervention also through some other clinician without your knowing much about it. So that can lead to the bias. And the next one is contamination bias. Contamination bias, what is contamination? It is not that something chemically has been contaminated. Here we're trying to say the control population gets exposed to the intervention in the community studies. Suppose some health education programs are being launched in one area, and there's some, very adjacent area which has been chosen as a control where that intervention was not given. So there is a likelihood that the things what they might have been as a health education might have been delivered to them, those participants might pass on to the other village nearby. So while comparing the data of the two areas, there is a possibility that the results may not be valid, because those people also started following the same thing what was told to them. So this is just, so usually what we do, we usually select a control area which is away from the intervention area. Just to add a point to it. Next. So as I mentioned, as I've told you that the points which are important, I have tried to concise it in a capsule through this presentation. So outcome variables, very important. It is important to categorically identify the variables which are needed to be used for estimation of sample size, inclusion, exclusion criteria, defining the outcome in terms of efficacy or other outcome variables of interest, so as to maintain the quality. आपने कुछ ऐसे variables छोड़ दिए या additional ले लिए which were not needed at all, and they could bias your results. Next. So identifying the right variables and their type of data capture from the CRF. So data quality issues at collection stage. Ensuring items in the data set ensure consistency while collecting the data. So before, the master chart is prepared, these things have to be taken care of. So it is not that the master chart preparation is something else. So these things have to be duly considered, then only your master chart will work. Considering the variables based on objective of the study. We've talked a number of times on this. Considering biases, particularly for soft parameters and health outcomes, so blinding, etc., should be ensured. Ensure the confidentiality and anonymity to the respondents. Of course, this is an ethical part. So survey design and justified sample is important consideration of quality, which come up at the analysis stage, such as computing confidence interval and testing of hypotheses, which impact the policy decisions. Quality does not mean that we're only looking for exact measurements. Quality is a bigger concept. As I told you, that manufacturing process, the raw material, howsoever good it might be, but the whole process the product has to be seen in terms of whole process. So if the sample size is wrong, so your results are likely to be wrong. So quality of the results are bad. It is not that only your raw data was good. So they all form the part of quality of the data. It is not only that you focus only of how you have to measure. Next. There is another concept which has recently come up. I was also new to it, but since whatever I learned, I try to share with you, right? It's a data integrity. Let me tell, I hope you understand what integrity means. One is honesty. Forget about this data integrity. What is integrity? One is honesty. One is integrity. If you're any professional system, if your report is being written, there's a column integrity, and your boss usually writes beyond doubt. If you're dishonest, you could be still saved, but if your integrity is doubtful, you are thrown out of the job. So in what integrity means? Integrity means being together, integral part of it. So that means it's a what it does. What integrity is? Integrity is basically a responsibility of being together. So that works for the data also. So data, and usually it applies to an organization, right? So I'll read out this and I'll try to explain you. I mean, maybe I can put a few more words to it. Data integrated is a concept and a process that ensures the accuracy, yes, completeness, consistency, and validity. We've talked about it, of an organization of data. We've talked. By following the process, organization not only ensures the integrity of data, but guarantees that they have accurate and correct data in their databases. Suppose any organization is having a data and the government immediately needs it, planning commission needs it. So you should be sure that the data is correct. That means it is your responsibility when you're passing on to that. So these things, what we have discussed earlier, those form the part of integrity, but the additional responsibility is added to their organization. The importance of data integrity increases as data volumes continue to increase exponentially. Yes, of course, because your decisions are making, big data analysis are being done based on artificial intelligence. So there it plays a major role. That means the data is taking a decision, something based on it is the system itself is trying to generate the results out of it, and you're trying to use it. So if your data is incorrect or it lacks certain features, then the results can go haywire. So it is important, if it is a large scale data of an organization, decision making is being considered through artificial intelligence, machine learning, or it could be anything, most recent ones, but this is very important. So it is a responsibility of organization to ensure that. Of course, individual also, but more focused on an organization. Next. There are different forms of integrity. Physical integrity. So physical integrity, what we have talked so much, integrity means protecting accuracy, correctness. That's we all understand. There's next is referential integrity. इसमें क्या होता? In the series of process that ensure data remains stored and in a uniform, there is a certain responsibility how to store the data for a system. So I always say that, of course, the computer people, the statisticians are important who handle the data, but the subject expert for whom the data is being used has to be an important part of the system. So database structures are embedded with the rules how to maintain a data that are defined, which ensure only appropriate data deletion, changes, and amendments. So that means there are certain rules where to do. Suppose, for example, I'll give you one. I can think of one small example. There might be many. Like clinical trial registry is there, which I was coordinator for a long time. And suppose a trial was wrongly registered. Let's say it was not to be registered, but got registered for some wrong information. But there was a rule, clear rule, that it can be mentioned, but the trial cannot be deleted from the data, because that was a commitment with the World Health Organization also. So there are certain rules. Now that it is there, it is wrongly registered. All information, but it cannot be removed from that. So there are certain, and if any data changes have to be done, who can do it? So all those things are defined. So these are the referential. Domain integrity, again, is similar to referential actually. A domain is classified by a set of values that table columns are allowed. Suppose you're talking about, so let's say, if I can say, suppose if it is a biochemical data. So there might be a rule that patient's detail identification and biochemical data. It is not that it should contain pathology data, it should contain clinical data. Maybe that might be with somebody else. So that depends. What has to be shared with whom? So in what form the tables are there? So it has certain integrity, user-defined integrity. That means who can use user authorization, although basically it means that rules and constraints around data are created by users to align with the specific requirement. Important part of confidentiality. So integrity means being together. I hope you're getting this point, that even if something is wrong within your system, you have to have certain process to present. I hope you're getting the point what I'm trying to say. Next. Some initial considerations for having a validator. Just again, reminders and connect to the earlier presentations what you have. Next. Research strategy is a core of the research design. So we talked about what kind of objective it is. So you have to have an appropriate research design. Suppose it is a long-term study, you have a less money, and you start planning the quad study or a prospective study, and you might lose the way in midway. So it was a wrong decision. So you should have gone for some alternative secondary data or a case control study, something, just a small example I'm giving. So you have to have a proper research strategy to achieve an objective, right? So you need to have a proper strategy with which you are familiar with, or you should have knowledge about it. Next. Choice of studies design, as I explained you. Often a trade-off has to be made between the ideal and the possible one. Doesn't matter. You can always define the, but don't go for the one which you cannot do it. Next. Considerations before data capture. Clearly understand the objective of the study. This is getting repeated, but very important. Identify the variables and its nature to be extracted. This is very important. Suppose you're studying HbA1c, and you're not measuring blood sugar levels, fasting, BP, etc. But later on you feel that is important. So you have to identify what kind of variables you need to take based on inclusion and diagnostic criteria, exclusion criteria, outcome, what we're looking for. So outcome could be, suppose it's a diabetes study. So outcome is whether you're only concerned with primary HbA1c or concerned with the blood sugar level. So this has to be defined clearly, and accordingly the variables need to be chosen. And so that would validate and maintain the quality of the study. Choose from the one of the above outcome variable. Next. Next. So this is addressing the data quality. कैसे हम कर सकते हैं? Standardization, define data quality matrices. What, I mean, range of the data क्या होना चाहिए, that I explained you in the beginning with that TV example, that I mean you concerned with ये होना चाहिए. Suppose blood sugar आपके system में 110 की जगह 111, 112 measure हो गया, okay, चलेगा. Serum creatinine 1 की जगह 2 measure हो गया तो नहीं चलेगा. So you need to have certain defined criteria what you look for. Validation, regularly validate the data. Reliability, of course we talked about it. Correctness of the data. Incorporate valid data entry system. Correctness of data to be possible hoga. Double data entry, etc. So that, because any human can make a mistake, but if there is an inconsistency in two approaches, you can always look back and what is correct and do good. Training, very important part. Educate the research team on collection of data management. Cross-check data points. That means monitoring. So if all these things are reasonably addressed, the data quality is likely to be reasonably good. Next. So let's coming to the data maintenance, which is through master charts. Let's see what it is. So data processing is an activity when data is collected, translated into usable information, right? So as we started with an example that you have a raw material, ultimately you process and you get a product. So the raw material was data in this case, and you process and analyze, and then you get the result. So again, coming back to that appropriate analysis, appropriate sample size is important to have. The process would be done, but if those components are not addressed, the processing, howsoever good it might be, may not lead to right results. So usually performed by data scientists or a team of data scientists and domain specialists. So always remember, it has to be done with a team. Data science is a recent subject, I mean, popular subject, but let me personally tell you, data science is okay. But if it is coupled with statistics, it can do wonders as it affects the end product. That is decision making. What is end product? Decision making. So any health systems which has to have a decision based on the results. So if all these things are taken care of, the results would be good. And ultimately, what is that? What is needed? Good health delivery system. Finally, acha health system mile. That's what one looks for. And health is the best treasure one can have. Next. So stages of data processing, data collection, data preparation. So master chart is data preparation, data input, processing, analysis, data output, interpretation. Okay, next. So what are outcomes? जो variables are important होते हैं, just these are again reminders. Health outcomes में क्या होता है? Worst one is death, then a disease. Somebody doctor says that the person life is at danger. Then finally he says, okay, जान का खतरा नहीं है, but ये है दवाई आपको जिंदगी भर लेनी पड़ेगी. The family feels quite happy कि ठीक है दवाई. So the person is suffering from a disease and taking a medicine. And disability. So it doesn't have a disease, but there's this. And the last one is discomfort or dissatisfaction. This is usually so whole health outcomes are within this one. So you have to appropriately choose the one and appropriately choose the variable so as to maintain your quality and the validity. These are reminders and repeaters what are next. So variable, of course, you all know qualitative, I'll not read it. Qualitative and quantitative hota. You can always see what kind of variable you need to have. You're measuring something. Suppose it is an Ayurveda study where the symptoms are very important. So there it is a possibility that you might be more focused on the qualitative data, along with coupled with the biochemical data. So which are hardcore data, which takes a form of quantity. So we have to define the variables accordingly, what we are dealing with. Next. So one is categorical variable, nominal variables. Again, a reminder of it. Nominal क्या होते हैं? Usually हम इसलिए we are talking about nominal variables are if they are there. That means suppose that is a disease is mild, moderate, severe. So what we try to do when we do data entry. We don't write mild, moderate, severe. We try to code it. We try to give the variables the numeric number 1, 2, 3, so as to have a standardization of maintenance of data. We'll come to it later. So nominal variables means you naming the variable. That's all. The value of the variable number is not playing any role. Next. Next. So quantitative, qualitative, continuous hota hai, discrete hota hai. Continuous means there are coming back to that school definition, what we learned in natural numbers or real numbers, infinite numbers lie between two numbers. That is continuous variable. Suppose there is a blood pressure of 150 and 151. It doesn't mean that the 150.5 doesn't exist, but the instrument what we are using has a least count of 1 mm of Hg, because 0.5 we don't need, but the value exists. So 150 and 150.5, again the value 150.25 exists. So we have infinite values. These are called continuous. But when you are talking the number of children, these variables are continuous, but they are discrete, because you have jumps from 1, 2, 3. Here the higher number or the previous number can be judged. Suppose the discrete number is 4. The next number would be 5 and the previous number would be 3. You know it. But if suppose the blood pressure is 150 mm of mercury, what is the previous number? What is the next number? You cannot judge, because there are infinite numbers. So this is just a theory I have tried to explain you what you must have studied in your school days. Okay. Next. So ordinal variables means we are using 1, 2, 3 codes, but they don't get 3 means something higher. But 1 and 3 does not mean that 3 is something which is 3 times the first one. Suppose you have categorized certain your pizza order from suppose you are asked to categorize the taste and delivery process between 1 to 5. Somebody codes 1, very poor quality, and somebody codes 5. Does not mean that that person was 5 times more satisfied with it. but the grading of satisfaction was higher. Who has coded 5 and the person who has coded 1 was very unsatisfied. So it is a gradient, not the numerical transformation. So these are called ordinal variables. So you have to look for it before your study design, that what kind of variable you're going to use it. And accordingly, the statistical analysis will follow. Next. Next, I've talked about it. Next. Next, I think you repeat over. Next. Next. No, so this is just enough. So consideration for data entry in Excel, of course, my younger friends, you must be much more trained than I am. So, but just so define the nature of variable. String hai, memo hai, numeric hai, integer with a decimal. Simple. This is basic thing you have to define in the way. If the value doesn't have a decimals, then take a numeric integer dal dijiye. Define such. This is an important point. What I mean, my experience, and so I have tried to share. Different subgroups of the data should be identified by individual identity. For example, systolic blood pressure and diastolic blood pressure should not be part of blood pressure. Medically, or for understanding logically, it's okay. But for a data entry part, you have to have an individual item. SBP, DBP, right? It is not that blood pressure and then further make it subgroups, because that makes difficult for a statistician to analyze. It is not that it cannot be done, but he finds it difficult. So this is just some general points which I have tried to, based on our experience, try to put. It is under the assumptions that all the variables uniform for subgroup of data. Okay, this is very important point. Suppose there's a case group and another control group. The variables are of uniform nature. That means your variable names are same. So as to have in comparison, the what value was in this group and what value was in other group. I hope you're getting this one. Next. Put the variable's name in the first row of the Excel file. Avoid special characters when naming the variables. Do not start the variable with a number. No space between the variables. These are just general guidelines. I won't say hardcore guidelines, but it makes the life gets easier for you as well as for a statistician who is helping you. Avoid using separate sheets for different subgroups. Usually this is what will happen. एक sheet में आपने case group डाल दिया, एक में control group, कोई जरूरत नहीं है. You can have a column of group which says case or a control. That's all. That's easier for analysis. Next. Avoid using text as much as possible. Codify the data instead of putting mild, moderate, etc. I've already told. Mild है तो what? Because the moderate somebody would write mild as MILD, somebody might write as a small m, MLD. It could be anything. I mean, so when one is there, one means one, whatever format you use. Next. Define the variable in the format section. Ordinal or the nominal variables, male, female, MF लिख सकते हैं. Better रहेगा 1, 2 लिखिए. Because small m लिख दिया, किसी ने italics में लिख दिया, the computer might read it differently. So you can be used. Continuous measure should be coded as numbers with decimal if required, and defining the decimal places. So what are important? No unit should be there in data cell. So it is there in the variable only. It is not that every cell you are writing centimeter or meters or something like that. So units की जरूरत नहीं होती उसमें. Even if it is a big number, the comma should not be put. Next. All numbers in the data field should be same units. This is again a common problem. 6 months old child, 2 years old baby. So you have to make it either years or months. But that depends. What the major data contributes, you can make the smaller ones in the same units. If situation arises, convert the same units. For instance, data in pediatric age group is on different. So I have told you. If one of the data points in cell is coded as text for a defined field, number field, all the items will get converted into a string field. This is a very important catch point. I also can. कि एक में गलती होगी सारी वो change कर देगा. So be careful about it. Choosing a format. Next. So software specialized programs can be developed or edited. That depends. SPSS are easily available. SPSS easily available nahi hai, but still people have it as trial versions, so you can always work with it. Info, WHO packages, and all these can be used to for using for analysis part. And of course, I suggest, yeah, of course, you're all well trained, but still seek help of, as I have already told, working for a research, working in a team is always healthy. Because something you know, something, I always think that somebody else knows you more than that. Or something else somebody else knows. It's not that I won't say more, but somebody else might know something else which might be useful. So this is just a humble, as a friendly suggestion. Next. So this is how the Excel form, spaces and Excel format looks like. Next. Next. So this is how the data are maintained decently, and they're easy to use. Next. Yes. मैडम एक मीटिंग में हम थोड़ी देर में बात करते हैं. ठीक. So need for a strong and efficient database for every scientist. Computer output obtained from these data exploration tools may be used in a variety of ways. They can be saved for future retrieval and use, be sent to other teams in electronic files, or to be disseminated online to communicate statistical information to users. So you have to have an efficient database which can be used. So integrity यहाँ पे आ जाती है. Output is usually governed by need to communicate specific information to a specific audience. So you need to have an output in the form based on the people whom you are addressing. If it is a scientist, it could be a common man. So accordingly, your results have to be there. For whom the output is being produced, how the audience will best understand it. So this is very important part. It is not that we have done our job, but we have to see who can understand it well, how one can understand it. Next. So need for a statistical support and medical research. It's not that I'm promoting something, but this is based on experience. I'm learning from you so that I learn from you so that I can best use the data, considering the nature of the data you have generated. So there's always a teamwork which helps. Works beyond data analysis. Let me tell you. Contributes in choosing the optimum design for you, choosing the optimum variables for the study, because of his experience, not because of his knowledge. More knowledge. Your researchers are knowledgeable, but some experience always helps us. Helps in providing the survey approach and collection of data. Coming out with the optimum sample size for the study. That's very important. By acquiring knowledge from the researcher. We tell the sample size when learning from you. Initially, we become your student, and then we try to tell you what is the sample size and what analysis is likely to be used. Next. So statistics is also, ethics, you all know it, that health is a subject which all research are similar in their approaches, but the additional component what health has is the ethical concerns. So sample size is not only the matter of concern for scientific committee, but also the institutional ethics committee. This is just a point I always highlight that. Ultimately, कहाँ पे quality of data बात हो रही है. That's what we started with. कि sample size अगर गलत हो गया, ethics committee ने भी pass कर दिया, without assuming that scientifically it was right, we are again going to land up with the wrong results, and wrong decisions could affect the health delivery system. So those are important points which I have tried to connect. Next, I think I'm through with it. So thank you very much for being with me, and something if you don't agree, you're free to do so. So this is what I've tried to put in one capsule, considering various aspects, giving certain connects, which I feel should be okay with you, but there's always a scope to improve. You can add to it. So thank you so much, audience. Thank you, organizers, for giving me the opportunity to be with you, and look forward to it in future interactions. Thank you.
Thank you so much, sir, for it's again an honor for us for your presence in this program. And sir is delivering all important session in every our program in offline or online modes. Thank you, sir. Thank you for your expertise.
Thank you so much for your kind words.
this program.
Thank you, participants, for your, your time. Your humble statements, what you have been giving, and I really appreciate. Thanks. And
Thank you all delegates.
any questions you have, you can send me. I have given my email. I have given my phone number. Welcome anytime.
Yeah. So if there is any doubt, you can share. You can share your query as soon as a response will be given. And we again met with sir on 10th July with one more important session on fundamental of testing of hypothesis. So tomorrow we again met at 6 p.m. with the scheduled session. So thank you everyone. Thank you again, sir, for your presence. Thank you for your time and contribution.
Thank you so much, participants, for your time, I should say.
This is the end of today's session. Tomorrow's session will start at 6 p.m. as scheduled time. Thank you. Thank you, everyone.
Thanks.